All right. Thanks so much, Jimmy. And thank you, Dream Sim crew, all of you for the tremendous talk. Hey, everybody. My name is Jacob. Apologies for the poor lighting and conditions of the room. It is 1 a.m. here, so not ideal, but here we are. So what we're looking at on the screen is the NIGHTS data set. So this is the data set that the team that just went put together. So this is visualized. It's publicly accessible. You can download it from their GitHub repo, and that's what I did. So I downloaded it from the GitHub repo and then put it into FiftyOne in this form with all of the metadata, so you can actually filter through it. So you can do things like click on an image and actually see not just that image, but the entire triplet. And you can see this is the left, the right, the reference image. We can do things like look at properties, so we can see how many votes each one got, and we can look at the total votes. So here, if I click on this, we can see that in this case, there were 8 votes that were cast, and the one on the left was actually the one that was chosen by the humans. All 8 of those people unanimously chose that. We can go through and look at a couple of these, and we can see, as we go, we've got more details there we can look at. We can also do things like similarity search. So what I've done is using the DreamSim embedding, the DreamSim model, and taking the embeddings from that, I have generated embeddings for all of the images in this data set. I've also generated embeddings with Clip and with ResNet, just to provide a couple of points of comparison. Not the exact same ones they did in their paper, but just gives a little bit to work with. So here we can do something like select an image. So we'll take this image of pho, I think that's what it is. And then we can click on this button right here and decide what similarity search we want to perform. And so in this case, let's say I wanted to, because we're dealing with the reference group slice, which again, this is all things that I've computed beforehand, but you can do this all yourself. You can decide how you want to slice and dice things. So let's say we want to look at, first we'll take the RefSim clip. So this is the reference slice with the similarity run that we've done with the clip model. We can click here, and then we're going to get the 25 most similar samples, and we get this. And we can see that it's pretty good. And so we get things that look pretty similar to this first image over here. A lot of them have bowls with chopsticks. A lot of them have pho, they have eggs in them and things like that. But there are some notable differences. So the background in a lot of them is a little bit different. So if you look at the you could call it like the texture or the pastels, the color scheme, that looks a little bit different in some of them. There's some of these that have like a wooden background and things like that. So not perfect. So we could say maybe it's more semantic and less like pixel patch level. Then we can look at something like, let's reset it, and we'll go back and look at the same image. Where was that? Over here. And we can look at let's take ResNet and look at that. And the reason that it's going a little bit slow is because I'm actually not using a vector search engine in the back end, because even though vector search engines are great, they do introduce oftentimes their own approximations into things, and we wanted to just get the exact results here. So this is just a brute force, not brute. This is an exact nearest neighbor search. So when we do this with ResNet, which is more on the level of individual pixels and patches, we can see the color scheme looks right in a lot of these things, but semantically it's not that close. So we have things like pork or steak. So there are some issues with this. But when we look at the ResNet one, we go back to the same image one more time, and we see here, click on this. We can see that it looks a lot better. So the first 8 images are all semantically and color and organization inside the image, very good fits. So that's just one example. You can do this for whatever images you want. So we could take the toucan here, and we can look at, again, what the clip similarity looks like, and we can see that it indexes very highly on like the type of bird, but not the background. And you can do this for the, here, let's go to ResNet. We can see that it gets a lot of like the branch right, like the background is right, but this is definitely not a toucan over here. Like some of these birds are definitely not toucans, but with DreamSim, things like this are handled a lot better. This, so looks a lot better. And these are just a few examples. You can click on whatever group slice you want. So here we're looking at, that's my bad on that one. But you can like click on whatever group slice you want. I've also saved some views. So here there is, I made a view that is left preferred. So this is, I filtered for all the cases where humans actually preferred the left image. And so we can look at like this here. Let's look at this. And so we can see in this case, the left image had 1 vote, or so had eight votes, and the right image had 0. We can keep on going through. But this is not maybe super interesting. Maybe it's more interesting to see things like where DreamSim agreed or didn't agree with human preference. And we can look at this saved view of all the places where DreamSim did not agree with human perceptual metrics. So we can see, okay, let's take a look at this one. Well, there were 4 votes here, and all 4 humans agreed, but this is actually kind of a close call. Like, it's not necessarily clear. I'm not sure if I would agree with what those humans said. There are some things that are a little bit more cut and dry, and those show, more, maybe some things that could be improved in the future, maybe with more fine tuning, maybe with a larger data set. But of course, it is very visible that this represents a step forward. The last thing that I wanted to show, and then I will give the floor to people who, to Philip, who will be showing some vector search stuff, which will come handy when you are doing things with thousands and thousands of images like I'm doing here. But I wanted to show you this. So in addition to a similarity metric, this like a similarity index, I've also done a dimensionality reduction with UMAP, Uniform Manifold Approximation, on all of these different embeddings, and then we can visualize those as well. So if we go to, let's say, ResNet here, we can see what this is. This is a 2-dimensional reduction of the embeddings from ResNet. We can see that it's very like clumped up. There's not a lot of spacing or there's not a lot of differentiation between them, which maybe gives us some insight into what's going on. We can lasso select a certain number of these points, and when we lasso select them, the images corresponding to those embeddings will show up. And we see, okay, well, again, pixel and patch wise, in this case, while there's a lot of water in all of these, this is a submarine, the first one here, but this one is a seal or an otter or a sea lion, whatever it is. It's a sea creature, so it's semantically very different, but they're kind of being grouped together. We can look at clip and see instead. So let's see, where is ref is clip over here. So it's better spacing. We can kind of look inside. So let me reset the grid. Okay, and let's look at like a little patch over here. Okay, that looks pretty good. Again, semantically, not like orientation wise. We can dig in a little bit. If you do this enough, I don't remember exactly where, but there are some patches that semantically they kind of mix 2 different concepts together in a way that is a little bit odd. And if you want to actually parse through that, there's a way to do that. And for instance, let's say we want to select this little patch over here. Or I'm just gonna look around a little bit. Let's find an interesting one. Come on, there's got to be something interesting over here. Okay, so what we could do is we can now click on one of these images. And now that we have that, we can instead change from this clip to a dream sim, and we can see where this image is in the dream sim UMAP embedding dimensionality reduction visualization as well. And we could even do a similarity search and see, let's say we wanted to look at the clip ones. So we can say, okay, let's look at up here. And we can click all of these, and we can see where they all show up here. So they are pretty clustered together in the same spot. So in this case, the clip, like the way that clip is representing things is in some sense very similar to the way that DreamSim represents things, but in some cases it's not. So this just gives you a way to understand better what's going on and kind of get a sense more intuitively for the differences between these embedding metrics. So that's it. I will cede the floor and cede my time, but I really appreciate everybody. Appreciate the DreamSim team for all the tremendous work they did. And Philip, the floor is yours.